Hello everybody, welcome to lesson 17.3, Heat and Changes of State. I'd like to review with you changes in state or changes in phase. That's when a solid becomes a liquid, becomes a gas, or a gas reverts back to being a liquid goes back to being a solid. Change in state or change in phase, okay? So melting are words we use, vaporizing are words we use, but they happen at a constant temperature, meaning while ice is melting, the temperature remains at 0 degrees Celsius. While water is vaporizing, the temperature remains at about 100 degrees Celsius. This is the normal freezing point of water, and this is the normal boiling point, okay? Or vaporizing point. How do we calculate Q? Please remember that when there is a temperature change, Q is calculated based on the mass times the specific heat constant times the change in temperature. The reason I'm reviewing that with you is because when there's a change in temperature, you can calculate Q this way, but when there's a change in state, the temperature is holding constant, you need to do something different. You need to change your grams to moles, okay? And then you need to multiply that value by what's called the molar heat, okay? So let's take a look at a few of these things. We're going to be starting with ice, and we're going to be creating steam. We're going to add heat. We're going to start with a solid piece of ice, and then we're going to create steam, which is, well, vapor, right? Or gas. Molar heat of fusion and molar heat of vaporization, I want to show you how they are written symbolically, and then I want to talk a little bit about this heating curve. Okay, not sure why this is not opening. Okay, so I'm going to sketch on this screen. And here we go. The molar heat of fusion is written like this, symbolically. It's a heat, and sometimes this little FUS abbreviation is put there. And it is equal to 6,000 joules, or 6.1 kilojoules, per every mole that you want to change from solid to liquid. Okay, notice this is happening at 0 degrees Celsius. What about the molar heat of vaporization? There you go. Every mole that you want to vaporize, you need 41 kilojoules for every mole that you want to vaporize. Where does this happen? At 100 degrees, right here. Liquid becomes gas. Okay. Now let's just take a look at the opposite, okay? Condensing and freezing. The words condensing and freezing, let's think about that. What is condensing? Let's see. It's when we take steam, if we're talking about water, and it becomes liquid again, okay? And freezing is when liquid, see, I had to think about it myself, becomes solid, okay? This requires the removal of energy or heat, okay? We're removing heat. So let's take a look at this heating curve again. By the way, the curve is really more of a step graph, if you will. We're going to take this many moles of steam and we're going to remove a lot of heat. We're going to change the gas to liquid and then to solid. It requires a little bit of heat removal. And what we're going to do is we're going to look at the molar heat of condensation and the molar heat of solidification. Let me show you where that is on the graph as I scroll down. Here we go. So if we start with steam, let's mark up where we are on this graph. If we start with steam over 100 degrees, we have superheated steam. And we need to actually cool it down to 100 degrees before we can condense it. Okay? And that would require the molar heat of condensation. We're removing heat. Once we've changed the gas into liquid, we can now start to cool it down. How much? From 100 to 0 degrees. That's a change in temperature problem. You can easily calculate Q times based on, Q. Okay. So getting back to where we are moving, we start here again with steam. And we're going to go all the way down to, here's a phase change. We're going to change the liquid into solid, and then we're going to cool it some more. Okay, and so we're going to use the molar heat of condensation and the molar heat of solidification. The molar heat of solidification right here, 6 kilojoules for every mole. The molar heat of condensation, we're removing 41 kilojoules per mole. I hope this helps you to understand how to do worksheet 4, chapter 17, section 3. Thank you.